As we talked about in the past video, the central aim in non-cooperative game theory is in trying to find the optimal strategy for agents to play within a game and trying to predict the outcomes of the game by finding points of equilibrium. This equilibrium is called the Nash equilibrium, and it is considered the best option given the absence of frameworks to support cooperation. This is what we call a solution concept. In game theory, a solution concept is a formal rule for predicting how a game will be played. These predictions are called solutions and describe which strategies will be adopted by players and therefore the results of the game. The most commonly used solution concepts are equilibrium concepts, where we look for a set of choices, one for each player, such that each player's strategy is best for them when all others are playing their stipulated best response. In other words, each picks their best response to what others are doing. In game theory, the term best response refers to the strategy or strategies which produce the most favorable outcome for a player, taking other players' strategies as given. Best response is when you know what others are going to do and you then choose your best response. Sometimes one person's best choice is the same no matter what others are doing, and this is called a dominant strategy for that player. Hence, a strategy is dominant if it is always better than any other strategy for any profile of other players' actions. A strategy is termed strictly dominant if, regardless of what any other players do, the strategy earns a player a strictly higher payoff than any other. If a player has a strictly dominant strategy, then they will always play that strategy in equilibrium. We say that a strategy is weakly dominant if, regardless of what any other players do, the strategy earns a player a payoff at least as high as any other strategy. If there are better strategies to take within a game, then there must also be worse strategies to take, and we call these worse strategies dominated. A dominated strategy in a game means that there is some other choice for the agent to make that will have a better payoff than that one, and thus it is dominated by it. When the game is non-cooperative and players are assumed to be rational, strictly dominated strategies are eliminated from the set of strategies that might feasibly be played. Thus, the search for an equilibrium typically begins by looking for dominant strategies and eliminating the dominated ones. For example, in a single iteration of the Prisoner's Dilemma game, cooperation is strictly dominated by defect for both players, because either player is always better off playing defect, regardless of what their opponent does. In searching for the equilibrium to this game, we would simply look at each cell and ask, is there a better option for the player? If so, then the cell is dominated and we should not choose that option. Once we've done this for both players, we can identify a corresponding cell or number of cells that is optimal for each, and this gives us the equilibrium or possibly a number of different equilibria. In games of conflict and competition, we're often interested in knowing what is the strategy that one can play that will reduce one's exposure to some negative event. For example, this might be a scenario of war, where we have a number of different options as to the routes along which we send our food supply to our troops. Along any of these routes, there is the possibility that the convoy will get bombed. We would then try to choose the option that will minimize the amount of damage that might possibly be caused to the convoy, and this is captured in the term min-max. Min-max is a decision rule for minimizing the possible loss for a worst-case scenario. The min-max value of a player is the smallest value that the other players can force that player to receive without knowing the agent's actions. A min-max strategy is commonly chosen when a player cannot rely on the other party to keep an agreement, or that they have in their interest that you gain the minimum payoff, such as in a zero-sum game. Calculating the min-max value of a player is done in a worst-case approach. For each possible action of the player, we check all possible actions of the other players and determine the worst possible combination of actions, the one that gives the player the smallest payoff. Then we determine which action the player can take in order to make sure that this smallest value is the largest possible. In contrast, a maxi-min strategy is one where the player attempts to earn the maximum possible payoff available. This means they will prefer the option which offers the chance of achieving the best possible outcome, even if a highly unfavorable outcome is possible when taking that strategy. This maxi-min strategy, that is often referred to as the best of the best, is also seen as being somewhat naive and an overly optimistic strategy, in that it assumes a highly favorable environment for the decision maker. In contrast, the minimax strategy is a more realistic strategy, in that it takes account of the worst case scenario and prepares for that eventuality.